Friends, hello again. It's your boy, Ryan Lemon. Welcome to this video. We're going to be talking about exponents and everything under the sun involving exponents. 8 to the third power times 8 to the second power. Not a big deal, but it kind of is. If you have a power, you have repeated multiplication of the same factor. 8 multiplying 8 multiplying 8 3 times. Here you have 8 multiplying 8 twice. And since these things are being multiplied together, you can see that this is actually a power. It could be written as a power. It could be written as the repeated multiplication of 8 to the fifth, or multiplying 8 5 times. Sounds delicious, I know. Now, be careful. This is the product of powers. And you have powers to a power. What? Power to power? That's crazy. Let's see what that looks like. If you have 3 to the fourth to the second, you've got something like 3 to the fourth. What you've got in parentheses here is what you've taken twice, with multiplication in between. There you have it. So really, we can use this property to finish this here power to a power property. 3 to the fourth times 3 to the fourth is really just 3 to the 4 plus 4, which is 3 to the eighth. Not bad. Am I right? Let's keep going. Careful, I don't want you to be tricked. That would be bad. Let's take a look at some of these tricky ones, which I don't think are too tricky once we see what's going on. Well, if you've got negative 2 to the fourth to the third, let's say, know that it's this stuff in here that we're taking 3 times. So really we have negative 2 to the fourth, careful, that's in parentheses, times negative 2 is to the fourth, and again, negative 2 is what's taken to the fourth power. So really you have negative 2 to the 12th. And by golly, we can actually have a shortcut here. If you multiply these ideas, you can have this here exponent. If you have a power to a power, you can multiply the exponents. So that's what we did. Know that your answer will be positive. Why? Because if you have a negative 2 that's going to be written 12 times like so, and you're going to keep going, then you'll have an even number of negatives, which would produce a positive number. So 2 to the 12th is a fair representation of negative 2 taken to the 12th. There you have it. Now, be careful, because sometimes when you're walking on the streets, you'll run into something like this. You've got negative a to the second and to the third. So this is really negative whatever results to the right of that negative sign. Because we have to remember PEMDAS. We've got to do our exponents in any multiplication, our exponents before any multiplication. And this negative sign out in front is pretty much like a negative 1 multiplying this result. So let's figure out what that result is. It's a to the second, listed 3 times. Or you can just think about the shortcut instead. You can say, it's a power to a power. I know it's a to the sixth. And we're taking the opposite of whatever that is. So negative a to the sixth. Make sure, even when you're given something for a, make sure you talk about it separately and then assign the negative value, or the opposite value. Okie dokie. Keeping on, keeping on. We've got this. Now, just like we're multiplying something like this, we need to write the numbers with the numbers. We can use the commutative property here, and variables with variables, so you've got 4x to the second. You've got a little intermediate step before you can go here with this problem over there. you've actually got a power to a power situation. You can think about it one of two ways again. Either this is written 3 times, like 3b times 3b times 3b, or you can think, I need to take the power of 3 and multiply these powers of 1 and 1. Do you see? So we really have 2b to the third times 3 to the third times b to the third. And we get these powers of 3, these exponents of 3, by taking this power, because it's to this power, and multiplying to this power and multiplying. The numbers, we have 2 times 3 times 3 times 3 is 27, I believe. And you still have this b to the third and this b to the third. What you really have is 54b to the sixth. Hooray! Moving on to negative exponents. I went over briefly in class the idea that 10 to the 0, I don't know. I know 10 to the first is 10. I know 10 to the second is 100. And 10 to the third is 1,000. We can continue this trend if we want, but I don't. So, as you notice, as you're moving backwards this way, you seem to be dividing by 10, and of course, this trend might continue, and those of you that know 10 to the 0 power is 1 can see that it is continuing. You're dividing by 10. As you keep moving, let's divide this result by 10 for 1/10 and 1/100th. And that means that it's 10 to the negative 1, and 10 to the negative 2, and so on. 10 to the negative 3 just means really 1 over 10 to the third power. You have that as a rule for your exponents. Anything written to a negative exponent, I'm talking very quickly for some reason, is 1 over that very power, but written as a positive exponent. And you can see the rationale behind this property up here in this example. Look it over it again. Pause it. See if you can see what's going on and how it really means. When you have anything written to a negative power, you can write it as 1 over that power, but with a positive exponent. This leads directly into the next thing I'm going to say. And the next thing I'm going to say is this. Something written as a negative exponent can be written 1 over x to the 7th. Now be careful. What if you had 1 over x to the negative 5th? That really means you have 1 over x to the 5th, according to this idea up here. But if you have 1 being divided by 1 over x to the 5th, that really means you have 1 times, because you keep, you change, and you flip. This really means you have 1 times x to the 5th, which is x to the 5th. So you mean to tell me that 1 over x to the negative 5 is really just x to the 5. Interesting. It appears as though, if you look back up here at the top, this is really over 1, and it ended up in the denominator. This is underneath 1, and it ended up in the numerator. This might be the rule. The rule might be better stated that if we have a negative exponent, we put it on the opposite side of the fraction bar. So something like this is as easy as, let's see this negative exponent and this negative exponent go on opposite sides of the fraction bar. Result, b still stays up there, do you see it? And then this b to the 3 to the third power comes up top with a positive exponent, and this a to the negative 2 comes down with a positive exponent. So on top you really have b to the 4th, and on bottom you have a to the 2nd. I'm done simplifying this here expression. Interessante. So that's just the same if you have 3x to the negative 4th, y to the negative 6th. We can call this 3 staying up top, because this negative exponent does not belong to the 3, it just belongs to the x. We can put that on the bottom, along with its friend, y to the 6th. Pretty easy. One more example for the road. Let's take a look at 4 to the negative 5, sure, times 4 to the 3rd. Well, we know by now that we can just add these exponents because it's a product of powers. So we've got 4 to the negative 5 plus 3, which is actually 4 to the negative 2. Uh-oh. 4 to the negative 2, you can't write a negative exponent, so let's go ahead and compensate for that by putting 1 over 4 to the second, which is really 1 over 16. Easy breezy, lemon steezy. Goodness gracious, great balls of fire. I think that's all I want to say today. You're welcome. Talk to you later. You hang up first. No, you hang up first. Did you hang up? Hello? Okay, bye-bye.